As we discussed in the prior lesson, TCP provides a reliable channel of communication between two different hosts, which is why it's considered a connection-oriented protocol. It provides the communication that's required between the network layer, which is the previous layer that we explored, and the upper layers. For example, when you browse to cyber.com, an HTTP request is encapsulated in an IT packet using TCP, and this request will reach Cyber's web server requesting the website's information. The server then replies with the requested data. And that's essentially how it works at a high level, but in this lesson, we're going to dive much deeper. And while we're talking about visiting websites, by the way, keep in mind that other applications also use TCP. For example, we have email, which of course is used for sending and receiving email. We have SFTP, which is Secure File Transfer Protocol, which is used to download and upload files on servers. And then we also have another example of SSH, which stands for Secure Shell, which is used to gain access to devices or servers with encryption. And there are many other examples, but these are just a few. So to understand how TCP works, we need to learn about something called the three-way handshake. Before a system can transfer data to another system, TCP needs an established connection, and it does this with a process that's known as the three-way handshake. And it gets the name because of the initial 3 packets that are exchanged between the requester and the receiver. The first packet is called a SYN packet, and this is the client telling the server, "Hello, I want to start a connection. Let's synchronize." And the server will then reply with a packet called SYN-ACK, which is the server replying saying, "Sure, I'm ready to start a connection. I acknowledge your SYN request." And then the third packet is the ACK packet. And this is the client saying, "I acknowledge that you're ready. Now I'll send the data." Now the client will send the HTTP request using one of HTTP's request methods, such as GET, head, post, put, delete, etc. And while we won't explain the details of what these request methods are or how they operate, since that goes beyond the scope of this course, when requesting a web page by visiting a website, you're getting resources from the server. And so you're typically using a GET request to retrieve the data. And as you initiate the GET request, the data transfer starts with the appropriate acknowledgement of packets. Now there's also a process to properly terminate the established connection. The client sends a FIN packet saying, "Hey, I'm ready to finalize our session." And then the server replies with an ACK packet saying, "I acknowledge that you're ready to terminate our session." The server then also sends a FIN packet of its own saying, "I'm ready to finalize as well." And then the client responds with a final ACK by saying, "I acknowledge that you're ready and goodbye." And so the whole process looks a little bit like this. Now, a common analogy to the three-way handshake is a phone call. Before you start the actual conversation, there are some steps that are involved between the parties. For example, the first person dials, the phone rings on the other side, and then the second person picks it up, and then some initial hellos are exchanged, letting everybody know that they're ready to talk. Now, since TCP is widely used, it is very important to understand how the three-way handshake works, especially for more advanced topics, since there are several types of TCP attacks, such as SYN flood attacks. This attack creates a huge amount of SYN packets to try and flood the target, and the server responds to these requests, but the client never sends back the acknowledge. So the three-way handshake is never actually completed. The server waits for the ACK packets that are never sent, exhausting the server's resources and making it unavailable to new and legitimate connections. And this is an example of a type of DOS, or denial of service attack. Now, of course, this is a high-level overview of TCP, and application developers, for example, might have to go into more details, like understanding sequence numbers, control bits, checksum, and other characteristics that TCP uses in order to guarantee a reliable delivery of packets. So while we will end the lesson here, definitely feel free to further research those topics if they are interesting to you. And then I'll see you in the next lesson.